we are going to take a look at some examples of using the integrals to find the volume of a solid. So recall from the last video, we took a look at if I have a solid that's being sliced up along the x-axis, then if I can find the area of a slice and integrate from a to b, we can find the whole volume. But we're going to use this idea, the volume equaling the integral from a to b of the area in terms of x. And we want to find the volume of a solid with a circular base of radius 6, whose cross sections perpendicular to the base and parallel to the y-axis are squares. So the base is a circle. The equation of the circle is x squared plus y squared equals 36. And we are slicing up our object that is coming up in this third z direction. We are slicing parallel to the y-axis, so perpendicular to the x. And when we slice this circle down, and then we split our object apart, and we're looking at one of the faces. We are looking at a square. So if this circle is the base, that red line is relating to the red line now of this square. And what our integral tells us is if we can find the area of this square in terms of x, we can integrate the area to find the volume. Now, we know several things here. First, to find the area of this square, any square is going to be the length of the base squared. So if I can find how long this base is, then we know the area. The length of the base is relating to this red line on our circle. Just at any x location where it's going between y and negative y, that height. So the base length is a length of 2y. But solving our equation of a circle, x squared plus y squared equals 36. This means that y squared equals 36 minus x squared, or y equals the square root of 36 minus x squared. So the base can also be written as 2 times the square root of 36 minus x squared. We're trying to find this area of the cross section that is a square. So again, the base squared is the area, meaning we're squaring this base. The area is really 2 times the square root of 36 minus x squared, all of that squared. Which gives us our integral we want to solve. We want to solve the integral of 4 times 36 minus x squared dx. What we don't have written quite yet is a to b, but our integrals in terms of x, so where is our circle in terms of x? Our circle goes from -6 to +6 because we have a radius of 6. So there's our integral we're going to solve. Working this out, we get 4 times 36x minus x cubed over 3 from -6 to 6. Plugging in our upper bound, we get 4 times 36 times 6 minus 6 cubed over 3 minus 36 times -6 minus -6 cubed over 3. And working all of this out comes out to be 1,152, whatever our units are. There is the area if we have there is the volume if we have a solid with circular base, radius 6, cross sections perpendicular to the base and parallel to the y-axis being squares. Now, suppose instead we want to find the volume of a solid with a circular base of radius 6 and whose cross sections perpendicular to the base and parallel to the y-axis are equilateral triangles. We're going to have essentially that same setup. Our integral is going to go from -6 to 6, but now our area function is going to change because now we're looking at triangles instead of squares that we were before. So we still have this circle being our base. That goes from -6 to 6. And we're still slicing perpendicular to the x-axis. But now we're looking at our area needing to be equilateral triangle. We know that to find the area of a triangle, we want to find the base times the height. In the last problem, we saw that the base was 2y, or 2 times the square root of 36 minus x squared. But we need to find the height of this triangle. Now, we know a little bit of geometry here. If I just look at this smaller triangle where I cut the height, here's h. We're just cutting that width of the base in half, so there's y. And because it's an equilateral triangle, cutting it in this way, we create a 30, 60, 90 triangle. Where that top angle is 30 and the side angle is 60. And the way side lengths relate to each other in a 30, 60, 90 triangle is that based on our angle opposite the 30-degree angle, the side is going to be twice that. The hypotenuse is going to be twice that. And then the height is going to be square root of 3 times the base of our 30, 60, 90. Meaning, for our area, our area of a triangle is 1/2 base times height. We have 1/2 times our base, which is 2 square root 36 minus x squared, and our height, which is the square root of 3 times y, which is, again, that square root 36 minus x squared. Multiplying all of this together, we get the square root of 3 times 36 minus x squared as our area function. Plugging this into our integral, we're looking at the integral -6 to 6, the square root of 3 times 36 minus x squared dx, which integrating that again gives us the square root of 3 times 36x minus x cubed over 3 from -6 to 6, or the square root of 3 times 36 times 6 minus 6 cubed over 3 minus 36 times -6 minus -6 cubed over 3. And this whole expression simplifies down to 288 times the square root of 3. So the volume now, when our cross sections are equilateral triangles, it's 288 times the square root of 3 units cubed.